purpose of this video is to evaluate the evolution of table tennis, or as it is more affectionately known, ping pong. Ping pong has evolved tremendously since its humble beginnings in the 1800s, and this is mostly due to upgraded equipment. What we're going to do today is evaluate the differences between a modern style foam paddle versus a more traditional style paddle. These first two clips both include world-class players, but are separated by approximately 75 years. It is very difficult to tell that they're even playing the same game. Ping pong was invented in England in the late 1800s and was initially a parlor game that you would just play after dinner. It was quite simple. That came to an abrupt change in the 1950s when all of a sudden they started putting rubber in the paddles, and that changed ping pong forever. This caused an explosion in enthusiasm as people were able to do things with ping pong paddles that were previously impossible. This led nations to handpick their single greatest individuals to represent their countries at world level competition. Though world championships have been going on in ping pong since the early 1900s, this was at a completely different level. Eventually, ping pong was added to the Olympic Games in 1988. The significance of the rubber in the paddle is it increases your ability to spin the ball. Watch as this man in the green is a master at spinning the ball and plays almost entirely defensively. Moving the hand leftwards will create a side spin in the clockwise direction, whereas moving the hand in the right direction does create a side spin but in a counterclockwise direction. Moving it downward creates a backspin, whereas upwards creates a topspin. Spinning the ball changes the trajectory of the ball as it travels through the air, but furthermore, it changes the direction of the ball once it lands. This brings us to the first fun experiment, and where we determine the difference in coefficient of restitution based on the different paddles. This is accomplished by dropping the ping pong ball from 90 centimeters, which is the initial height, and seeing how high it bounces, which is the final height. Then you do final height divided by initial height, and that gives you your coefficient of restitution. It is important to note that the modern paddle had a coefficient of restitution that was less than half of that of the traditional paddle. This is because the thin layer of rubber and foam can absorb the impact, and therefore you can manipulate the amount of force that you put into each play, and therefore you can manipulate the rate of speed of the rally. Although the traditional paddle has a much higher coefficient of restitution, the modern paddle has a much higher coefficient of friction. This is what allows you to have more pinpoint accuracy of where the ball goes and ultimately put more spin on it. We evaluated these paddles by performing three basic types of serves: a backspin serve, a side spin serve, and a serve that had no spin. Each paddle went through each serve 3 separate times, so we could get averages. With these averages, we were able to calculate the velocity, acceleration, force, work, and power for each type of serve with each paddle. We use the following formulas to complete our calculations. Distance over time is velocity, mass times acceleration is force, force times distance is work, force times displacement over time is power, and change in velocity over time is acceleration. The foam paddle backspin averaged a velocity of 3.66 meters per second, an acceleration of 5.63 meters per second squared, 0.15 newtons of force, 0.31 joules of work, and 0.46 watts of power. Foam paddle side spin created a velocity of 5.71 meters per second, an acceleration of 15.02 meters per second squared, 0.41 newtons of force, 0.89 joules of work, and 2.31 watts of power. No spin with the foam created a velocity of 5.08 meters per second, acceleration of 10.8 meters per second squared, 0.29 newtons of force, 0.69 joules of work, and 1.47 watts of power. spin with the plastic paddle had a velocity of 3.89 meters per second, acceleration of 7.34 meters per second squared, 0.2 newtons of force, 0.41 joules of work, and 1.47 watts of power. Side spin with plastic had a velocity of 5.62 meters per second, acceleration 12.42 meters per second squared, 0.34 newtons of force, 0.85 joules of work, and 1.89 watts of power. No spin with the plastic paddle created a velocity of 6.07 meters per second, acceleration of 14.45 meters per second squared, 0.39 newtons of force, 0.99 joules of work, 2.36 watts of power. It is important to note here that greater numbers do not necessarily mean greater value. The traditional paddle had greater numbers in virtually every single category. The only serve where the foam paddle was superior was the side spin. This is because when you can add spin going in the forward direction, you can allow the ball to actually gain velocity. The plastic paddle produced greater numbers simply because it has a greater coefficient of restitution. Because of this greater coefficient of restitution, it means that the ball is going to travel faster off the plastic paddle than that of the foam paddle. In conclusion, we had tremendous amounts of fun with this project due to its incredible scientific value. This project required us to take elite athletes and put them under incredibly difficult circumstances. The coefficient of restitution test supported our hypothesis that the traditional paddle would generally create greater numbers. However, the foam paddle not only has far superior control over the ball, but can actually produce greater numbers for side spin, because by putting forward spin on the ball, you can increase its velocity. Our hopes is that you learned something from this video, as ping pong is not only a very fun activity, but can be broken down into very sophisticated science. Furthermore, we ultimately hope that this video has inspired you to start playing ping pong, or if you already do play ping pong, play more of it, because it's a fun activity and it's great for